of sugar in your coffee. Stir until it's sweet as it can be. You look down deep near the
First, we'll observe the effect of changing the concentration on the equilibrium. The equilibrium that we'll study is one of dichromate in equilibrium with chromate ions. Dichromate is orange in solution, while chromate is yellow. We'll observe the effect that adding HCl and adding OH- will have on the system.
Dynamic equilibrium, dynamic equilibrium. When the rates of two opposing reactions are the same, dynamic equilibrium. So let's get back to that coffee cup. Nothing's going on, but wait. At the surface of the sugar, molecules dissolve and recrystallize at the same rate.
In the first example, we added H+, which increased the concentration of the H+ ions in the equilibrium. This stress caused the equilibrium to shift left. Next, we added OH-, which reacted with the H+ and lowered the concentration of the H+, causing the equilibrium to shift to the right. Next, we will try to determine if an equilibrium is exothermic or endothermic. The equilibrium we'll study is the equilibrium N2O4 in equilibrium with NO2. N2O4 is colorless, while NO2 is brown. We'll observe this equilibrium at 3 different temperatures: at a high temperature, at room temperature, and at a low temperature.
Now Shockley had a principal, and I don't mean the head of his school. He observed chemical reaction.
As observed by the increased intensity of the brown, increasing the temperature shifted the equilibrium to the right. This means that heat is a reactant, and the equilibrium was shifting to the right in order to use up the excess heat. This was confirmed by the decrease in temperature when the equilibrium shifted left, trying to replace the heat that was lost. Therefore, the reaction is endothermic, and the delta H is greater than 0.
Dynamic equilibrium, when the rates of two opposing reactions are the same. Dynamic